we're going to talk about probability of compound events. So a compound event consists of two or more events linked by the word and or. Okay, so I put and/or. So it's going to be one of them. Okay, mutually exclusive means they have no outcomes in common. So if I said red, black, an even number, an odd number, those are mutually exclusive. Overlapping events, at least one outcome is in common. Okay, so that might be like multiples of 2 and multiples of 3. So 6 is in common between those, so that's overlapping events. So if I'm mutually exclusive, if there is nothing in common, so probability of A or B, I have the probability of A plus the probability of B. So this is, we'll talk about this in just a second. And then we have the probability of overlapping events. So probability of A or B, so I have the probability of A plus the probability of B minus the probability of A and B. So those ones they have in common. So our first example here is, let's say we have a 20-sided die. And we're going to roll that 20-sided die one time, and we want to know the probability of getting a 2 or a 5. Okay? So these are mutually exclusive. I can't roll a 2 and a 5. I can only roll one of them. And so what we're going to do is we're going to actually have the probability of 2 plus the probability of 5. Well, the probability of 2 is 1 in 20, plus the probability of 5 is 1 in 20. So that gives me 2 out of 20, or 1/10. 1/10 of the time, I'm going to roll a 2 or a 5. Now we're going to look at a little bit different here. So what's the probability that I will roll a multiple of 2 or a multiple of 5? So now we have some commonality here. So the first thing is multiples of 2. Well, that's even numbers. So there are 10 even numbers. So there's 10 out of 20. So you're half the time you're going to roll an even number. Now, multiples of 5. So we have 5, 10, 15, 20. So there's 4 of those, 4 out of 20. Now, some of those are also included in the multiples of 2. So all the even numbers are included. So if I look at the multiples of 5 again, that was 5, 10, 15, and 20. These two, 10 and 20, also are included in the multiples of 2. So I have to subtract those off. So I have to minus 2 20ths. So I'm going to add these together. 10 20ths plus 4 20ths is 14 20ths minus 2 is 12 20ths. I will reduce this down. 4 goes into both of them. So this is 3/5, or 60% of the time, we're going to have a multiple of 2 or a multiple of 5. Okay? Now we're going to look at the probability of 2 independent events. Okay? So this is the probability of A and B. This is going to be the product of their individual probabilities. So this is the probability of A times the probability of B. So we're going to look at that. We're going to look at a couple of examples here. One where we just roll 2 different number cubes, a red number cube and a blue number cube. We're going to roll the red one first and then roll the blue one. So what is the probability that you will roll a 3 on the red cube and then an even on the blue cube? So the first thing is that they don't have any probability in common, right? They're not sharing anything. The probability of the red cube isn't changing the probability of the blue cube. So I look at the probability of rolling a 3. Well, that's 1 in 6. Okay, so then I look at the probability of an even on the blue. Well, that's 3 out of 6, or 1/2. So the probability of rolling a red 3 and a blue even number is going to be the product of these. 1/6 times 1/2. Well, we multiply straight across, so that becomes 1/12. 1/12 of the time, you would expect to roll a 3 on the red cube and then an even number on the blue. So let's look at another example. It says the probability of drawing a red card in a standard deck of cards you replace the card and then draw a diamond. So what's the probability of drawing a red card, replacing that card back in, so we're not changing it, changing the outcome, so the sample space, and then drawing a diamond. So the first thing I want to know is the probability of a red card. Well, what's the probability of a red card? Well, in a standard deck of cards, that's half the deck. Okay, half the deck are red, half the deck are black. Okay, so then I want to know the probability of a diamond. Right, so I draw that first card, I take it, I look at it, I see what it is, I put it back in the deck of cards, and so now my deck is still the same as when I had my first one. Okay, so now the probability of a diamond, well, if you're familiar with a deck of cards, there's 4 suits. One of them is diamonds. Okay, so there's 1/4 of the cards are diamonds. And so now we're going to look at the probability of a red and then a diamond is going to be the product of these. 1/2 times 1/4 is 1/8. So 1/8 of the time, I would expect to draw a red card and then draw a diamond. Okay? So we're going to look at, so that's independent events. What happens if I have dependent events? So we want to look at the probability of dependent events. So the probability of A and B, given that they are dependent, probability of A times the probability of B after A. Okay? So we have this unique probability here. Okay? Oops. This is not and, this is then. Okay? So probability of A, then the probability of B. Okay? So we're going to look at an example of this. And so it says, suppose you choose a tile at random from 12 tiles. So if you're looking in your book, it's actually referring to problem 3. Okay? So it has, so if you don't have your book, there are 3 dragon tiles. 4 dot tiles. 2 bird. 1 flower. And 5 square. Okay? 10. Should be 15 there. So there's 15 tiles. Okay? Without replacing, you select the second tile. So suppose you choose a tile at random from the tiles shown in our example here. Without replacing the first tile, you select the second tile. What is the probability that you choose a dotted? So I'm going to choose probability of a dot, then a dragon. All right? So what's the probability of choosing a dot first? So the probability of choosing a dot here, well, I look over here. I have 4 dots. Okay? So the probability of 4, so I have 4 out of 15 times. Now, once I pull that tile out, I now no longer have 15 tiles. I have 14 tiles. So my next probability is going to be out of 14 instead of 15. And then it asks for, so I've already taken one of these dots, now it has 3. And I want to know what's the probability of drawing a dragon. Well, that's 3 out of 14 because I did not replace that tile. All right. Now, I'm going to do some simplifying. You could multiply this all the way across and then simplify at the end. So I'm going to simplify here. That goes in there 5 times. 2 goes in here. 7. So this gives me 2 out of 35. So 2 out of every 35 trials, I would expect to pull a dot and then a dragon, okay? So let's look at one more example. This is dealing with an essay contest, okay? So we have 1 freshman, we have 2 sophomores, 4 juniors, and 5 seniors. Receive top scores in the school essay contest. To choose which 2 students will read their essay at the town fair, two names are chosen at random from a hat. What is the probability that a junior, so we want the probability of a junior, then a senior is chosen? Okay? So the first thing is we're going to look at the probability of a junior. Okay? So we're running this in order. So the probability of a junior, so I have 4 juniors over how many total? So I have 12 total, so that's 4 out of 12. Okay? I could reduce it down to make it 1/3. We're going to keep going though. Okay? And then I'm going to look at then the seniors. Remember, once I've chosen that junior out, this changes. Okay? So it goes from 12 down to 11. So I look at the number of seniors. I have 5 seniors. Now I only have 11 choices. So this is very specific though. Junior, first pick, then a senior. It's not saying a senior and a junior. It's saying what is the probability that I will get a junior, then a senior. Okay, so I'm going to reduce this down. This becomes 1/3. 5/11. I'm going to multiply this across. 5 out of 33. Okay, so that's probability of a dependent event. Dependent event means that what's going to happen is your probability is going to change on the second one. It's dependent about what happens in the first one. Okay, so that's probability of compound events.